changeover with the exception of the tooling. The tooling now is the longest change order. When you have to change from disc cutters to soft round bits on a 12-meter machine, you've got 60, 70 bits you have to change. That's typically taking the longest time. So depending if we're under pressure or not under pressure, meaning face pressure at any of that particular time, that is the biggest factor in the changeover from open mode to closed mode, or from rock mode to EPB mode. It's the cutter head and the cutter head tool changes. If we can keep the cutter heads, let's say we have disc cutters that are operating in rock, but now we have to have the same mixed face disc cutters operating in EPB mode, that conversion can be done really quickly because everything is hydraulically operated. The muffling is hydraulically operated. The changeover from disc cutters, or changeover from rock mode on the cutter head, is fairly quickly, and that kind of brings us back to the point of cutter and wear advantages in the discs in the tooling itself. So the long answer, the short answer, whatever you want to say, is if we don't have to change the disc cutters, it can be achieved pretty quickly as far as the changeover time is concerned, from screw mode to belt mode.
Well, that's going to depend, this is Brad, that's going to depend a little bit on the size of the machine as well. And so some of the features that we put in, obviously we're going to have more options for more equipment on a larger machine. As the machine gets smaller and smaller, we just don't have enough physical space to put in a lot of those duplicate systems. So it depends on some of the features that we're putting in and the size of the machine. So as Doug said, especially on the bigger machines, we have more options that are available to us, where changeover time can be really brought down to where it's changing the tools more than anything else.
Okay, and the next question, what is the minimum diameter for a hybrid TBM that would still be feasible?
It depends on if we want to have a full. When we get to the metro sizes, we're running into problems of where the screw location is, whether the screw location's in the bottom of the mixing chamber or the screw location's in the center of the mixing chamber. In a hybrid machine, we like to try to keep the screw in the bottom. It's most effective when it is in the bottom. We have put it in the center, and when you have a center-mounted screw, the changeover from belt to screw is fairly easy. We can do it in 6-meter machines. We've done it in 6-meter metro-type machines. The full features, as Brad alluded to have the full features of a retractable muck ring and all these enhancements, you need a machine in the 8, 9, 10-meter range. If we're into the metro size of 6-meter ranges, they can still be hybrid-type machines, but the changeover and the design of those changeovers is just a little bit different. We can even get them into smaller machines. I'm thinking now, the machine we have, small machine, 2.8-meter machine, operating in Florida. That's a bit of a hybrid, going from slurry to EPB mode. But it did have features where we could take the screw out, which was located in the center, and effectively put a belt conveyor in there. So, a hybrid type machine really is not going to be diameter dependent. What will be diameter dependent is the features we can apply to that hybrid type machine to make the changeover quick.
Okay, and the next question, what would be better, to have a hybrid TBM, one hybrid machine, or to have two machines that are fit for the geology? When does a hybrid TBM become more favorable?
That's a good question, and that's probably more driven by cost and schedule. Typically, two machines will bore faster than one. So if you had a clear line of demarcation where this tunnel side is rock and that tunnel side is EPB muck, then the two machine option will get the tunnel done quicker. Probably going to be more expensive too. So I think the decision on one machine versus two is the classic decision of cost. The design of a hybrid machine will get you through both geologies at a less overall project cost, but you'll suffer on the schedule because it just won't get done as fast. Two machines are always quicker than one.
Okay, and I think this is our last question. Do you think that a universal TBM will one day be possible?
A universal TBM, that's the classic question everybody asks. I think we're getting there. I think we have a long way to go. There are clear advantages that having a pure ETB machine and a pure rock machine for that geology. And we'll never get there with a universal machine. There will always be some I guess design considerations that you just can't build everything into one machine. But we certainly can look at machines that can go from varying geologies in a cost-effective way. So the classic universal machine, it's getting there, and there's still some places to go and some ways to go. But I think in long and short, there's still pure. I don't ever see in the industry buying one universal machine and working that machine on 5 or 10 or 12 different projects, whether they're rock or soft or how it is. That probably won't happen. But there's certainly advantages to taking driveline components and putting them into a rock machine, and then putting them into a classical EPB machine. So this is that universal machine. Maybe some parts are universal, but the cutter head is always where you need to design that cutter head for each project and the features of that cutter head. So it's going to be difficult to design a cutter head with all the features you need from the hardest of rock, 350 MPa rock, to the running sand. That's just not going to happen. You have to change the cutter head.
Okay, so that concludes our Q&A session. I know we didn't get to some people's questions. We have your email, and we will make sure to follow up with you.